Good afternoon. Hello. Engage. Engage, people. Engage. I know we're in Britain, but you can still engage. I'll stop making. That was my only political joke I'll make. And in fact, if I make any jokes, it'll only be about Spain and the civil war that's going on right now. Anyway, welcome to this talk on the importance of syntax in clean code. In clean code. Now, this is a theory I have. You might not agree with it. It doesn't matter. You've got to listen to me anyway. But we'll start with what exactly is clean code. And I went to Google and I said, what is clean code? And it sent me to an article on QCon, which was on InfoQ, which had, for me, done the job for me. It has summarized the importance of the meaning of clean code based on different people. So there was Bjorn Storstrup that said that, and I'm not going to read the whole thing, but I tried to highlight some of the important parts. And he was saying that the logic should be straightforward and make it hard for bugs to hide, the dependencies minimal to ease maintenance. Then I went to the next one, and it was by Grady Booch that said clean code reads like well-written prose. Scroll down. Big Dave Thomas said it has unit tests and acceptance tests. It has meaningful names. Now, there's way more in that. I just highlighted the first phrase, right? Michael Feathers said clean code always looks like it was written by someone who cares. Ward Cunningham, you know you're working with clean code when each routine you read turns out to be pretty much what you expected. Now, I've got my own quote. Clean code is a means to an end. For instance, you say you want to present a talk on Kotlin at a conference that is focused on topics such as clean code, use the words clean code in the title. Now, you might find this funny, and it's funny because it's actually a true story, right? They invited me here, and I said, I'll talk about Kotlin. They're like, well, be that. I said, look, I'll tell you what, I'll talk about the importance of clean code, but then I'll show Kotlin. But it is also true to a sense, right? Because I personally believe that, like, first and foremost, you realize that clean code is essentially something that's subjective, right? What you might find clean code, someone else might not find clean code. You get a developer that looks at a language they're not completely familiar with, construct, syntax they're not familiar with, and they'll say that it's not clean code. And you might say it's absolutely clean code. What is a little bit more objective is that messy code is, that is something that's quite objective. And noise, we also agree on, that can make things somewhat messy, right? And mess can distract. So reducing noise minimizes distractions. Now, that's my hypothesis. If you don't agree with it, as I said, you're out of luck, because this is Kotlin, and this is what you're going to see, okay? So what I want to do is I want to focus a little bit on Kotlin and show you what we've tried to do with the language in terms of minimizing boilerplate, minimizing code, and reducing the noise that you often get when you are working with some other languages. And for the sake of comparison, I'll use probably the most verbose language that exists, which is Java, because it just makes my slides much easier. So yeah, I won't set the bar high. So here's a Java. Let's start with the Java bean, right? Now, I tried to make these slides as readable as possible. The problem is that depending on the amount of code, I had to change the size of the font. Sometimes it wouldn't fit on a single slide. This is a Java bean. And you can see all of the stuff that is there, right? This is the equivalent in Kotlin. Okay, so the point here, of course, is that you say, okay, well, that is something that is generated for me with the IDE, which is true. The issue is that the IDE doesn't maintain it for you, right? Or at least not yet. The issue is that when you look at that code, you don't know exactly what it is that you're looking at. You don't know if it's something that the IDE has generated for you, or is it something that you've customized. And that, in turn, adds complexity. Right? Because what is this that I'm looking at? So Kotlin approaches that by just writing it as essentially what's called the data class. And here you can see that essentially what I'm doing is I've got the constructor in the same line, I have the properties in the same line. So I have the ID, which means that it's a read-only property. I have var and email, which are read-writes. And then this data over here, this modifier, what this does, essentially it provides you a bunch of functionality, namely toString, clone, equals, get hash code, etc. So you have this same implementations across anything that you write. Okay? And we try and follow this kind of minimizing code and making it more concise and readable in everything, even little things like casting, right? So here, again, you've got some code in Java that says, is an object an instance of view? And if it is, then initialize it. Now, you see here that it kind of feels like, why am I adding this? What is the point of doing this if I've already checked that this is, in fact, an instance of view, right? The equivalent here with Kotlin would be, you don't need to, because the compiler has already validated that for you. Why add that noise, right? Things like conditional expressions. Take a look at this. I have a whole bunch of code here that essentially what it's doing, first of all, I've got an int setting a value to 0, right? And then I have a switch statement that says, okay, based on the value, assign the actual, then do a break. Then I've got a case down here which is in the range of, okay, what happens if it's not a concrete value? I need to check, for instance, if it's in a specific range. So here I have this value that I have to initialize as 0 and then do all of this, right? How do we try and solve that with Kotlin? So first of all, we treat case statements, which is the equivalent, which would be a when in Kotlin, as an expression. And in fact, pretty much everything in Kotlin can be an expression. Right? An if statement can be an expression, a when can be an expression. So you get rid of that first initial initialization, which already means like I don't need to know whether this has been initialized only for the purpose because I have to set the value later on. Secondly, you introduce a read-only mutable property, which also gives us insight into now I don't have to worry about this value changing later on because I know that it's only been assigned once. And then it's got nice little things over here which allow you to do things like, check in ranges or check whether it's a valid function, or you can actually call a function whether it's cast it to a type. Now the lines that you see here, this 20, 30, 30, 20, 40, that in fact is telling you what the return value is of that one expression. So that's a convention that is followed in Kotlin, that the last line of a case statement or the last line of a if statement is the actual return value that is being assigned to the expression of that if or when expression. Okay. So again, it is not revolutionary. It is just about being more focused on expressing your intent. Now, one of the other things that we try and do with Kotlin is eliminate the idea of nulls, right? So again, this is your typical Java code where I have a customer that can be of type null, and then when I want to access that name, I have to check whether the customer is not null, and then I have to check whether the customer name is not null, and then essentially get into the actual code that I want to validate. If you think that logic is really crazy, I'll remind you that I live in Spain. So the equivalent of what we do here in Kotlin, well, we don't have nulls, right? So given that the language by default, a type cannot be nullable, we don't need to make null checks, right? So already I've gotten rid of all of that boilerplate code of checking for values of null. Now, one of the issues with this is that we actually interop quite a bit with Java, right? One of the selling points of Kotlin has always been the interoperability with Java. So what that does is that when I'm interoperating with Java, I can add this question mark at the end of my types. You can add that for Kotlin types or for Java types. And essentially what that's saying is that now my type can be nullable, right? So it goes back to the scenario where anything that I consume from Java, a function, a method, anything can return a nullable type. So I have to take that into account. And in Kotlin, you represent that with a question mark. But then we try and cut down the boilerplate code a little bit by using this safe operator, which essentially means if the customer is not null, then access name. If the name is not null, then access start with, right? This would be the equivalent in Java of what you would consider kind of like optional, right? But again, we're not going to do character by character comparisons, but there is a little bit of clarity when you cut down all of those method names and boilerplate code that you find over and over again, right? Avoiding repetition. Now this is a typical example that you have in Java, right? I have an overloaded version of print message, and in fact, there's a bug on this screen, right? What is that bug? Because, well, I've highlighted it in red. Can someone tell me what the bug is? Yes, the prefix comes after the message, right? So I'm writing the same code over and over again and only slightly changing the behavior, right? The behavior is now saying that, in this case, I'm passing a method with a single parameter. In this case, I'm passing the prefix, and in this case, I'm passing the prefix and the suffix. How do we solve this in Kotlin? It's very simple. It's been solved. The issue is already there. It's been solved in languages such as C#. It's called optional parameters. It's called default values, right? So essentially, I've cut down those 3 methods to a single method, which essentially is saying to me, the 3 parameters that I'm passing, I can pass default values, and I get the token of the bonus of also string interpolation, which means I don't make that mistake of positioning where I have to put what, okay? Adding clarity again. Dealing with collections. In stream, in Java, numbers. In stream, range 1 to 100. The equivalent of that in Kotlin, 1 to 100. Expressing intent. List of customers as array list, new customer Java, new customer Java. Or actually that would be mutable, so you would have to do something immutable as that, right? And in Kotlin, it would, you wouldn't need any of this. This is, the new actually goes in Kotlin. This you just have as list. Some of the things that you're bringing in with Java 9 as well, and Java 10 and so on and so forth, right? Now let's focus on something that everyone's focusing on, which is functional programming, right? Because if you're not doing that today, you're not doing anything, right? So, well, it's true, right? How many of you have read the book Object, the Gang of Four? Right, okay. Now go to some conference where functional programming is very hip, such as a JavaScript conference, because they also think they invented it, and raise your hands. They'll look at you weirdly. So here is an interface in Java, which basically says, it's an interface, it's a single abstract method, right, that I'm handling a request. But the point here is the method, the static private get. Here I have a parameter that is string, and then I have an interface that is root handler. Now, when I write code like this in Java 8, right, the IDE will say to me, well, you don't need to implement a single abstract method. You can convert that into a lambda expression, right? We all know. How do I know that that's a lambda expression? I don't know. If I look at the declaration of that, I really don't know that I could pass a lambda there. Right? The only way that I will find out is if I dig into the interface, if the interface says to me that it's a single method, and then I know that in Java 8 I can pass a lambda. Otherwise, there is no way for me to find that out, right? How do we try and solve that in Kotlin? We are consistent in how we declare our higher order functions, right? So get is in fact a higher order function because it's a function that takes another function. So in Kotlin we just do path string, and then you have your parameters and then the return result, okay? Now here you have unit, which would be the equivalent of what you would know as void in Java. The difference is that Kotlin unit is actually an object, so you can query on it as well, right? And objects exist in Kotlin alongside instances of classes. So you have classes, then you create instances of it, and then you have the equivalent of what's called an object as well, right? Similar to JavaScript. The point, though, here is that it is clearly marking the intent of what my code is and what my code expects. And if I have multiple parameters, I just add multiple parameters. If I have different types, int, string, int. Difference being that I don't need to now remember about bifunction and all of these different interfaces that you need to pass in the case of Java when you want to declare higher order functions. It's always consistent in what I am providing. A single parameter function, that's a int and returns nothing. Okay? That in then turn is a method, essentially. That's a function that doesn't take any parameters and doesn't return any values. But it's always consistent. Now with Java, I have to do something like this, by consumer. And remember these interfaces. And whoever looks at that has to figure out, oh, this is what exactly this means. And of course, this is in terms of declaration, in terms of using. There's also a little bit of cut down as well. And here, again, Java 9 and Java 10 is moving towards this. Right? So here, for instance, I have a set on click listener, and I'm passing in a parameter that I'm actually not using. I don't want to use that. Why can't I clearly mark this intent? In Kotlin, you don't have to use it. Right? If you're not using the parameter, the first parameter passed in, you just say, I'm not using it. And we borrow some things from other languages, such as Haskell and Scala and stuff like that. So for instance, here I have a lambda expression that takes two parameters and returns the sum of them, right? Now, if I'm not using one of those parameters, I can use underscore, clearly marking the intent of what my code is doing. I am not using that parameter. Don't take it into account. If I'm only using a single parameter, I can declare it like that, or I can borrow from Groovy and say it plus 1. Right? In Groovy, if there's only a single parameter, I just say it plus 1. And notice that between these two things, another thing has happened, which I've removed the brackets. Right? Because the brackets, if there's the last parameter to a function, if it's another function, I don't need to put it inside the brackets. And you would say, why? Well, it looks nice on a slide. No. Because I can then do something like this, and I can do kind of multi-line things, right? And we'll build up to this and see where this is going to take us. It takes us, guess where? To clarity of code. Talking about clarity of code, let's look a little bit about semantics, right? So we have this thing in Kotlin called the type alias. The type alias says that one type is equivalent to another, right? At runtime, they're the exact same type. Where I have a customer name, here I'm saying that a customer name is a string. Anywhere where a customer name goes, a string can go. Anywhere where a string can go, a customer name can go. That's what an alias is. Right? But it is giving me the ability to express a little bit more intent on what I'm trying to do. Right? I say that my customer has a customer name. Right? Now, this also allows me to do other things, such as, let's say I have this customer class here, and at one point in my life, I want to, pick on developers that consume my API, and I want to change this, right? I want to change the customer name to something like awesome customer. So what I can do is actually leverage these kinds of things like type aliases. And I can say I'll introduce a type alias, custom is awesome customer, bind that with an annotation called deprecated, which tells me that a customer is now called awesome customer, and in a two-phase stage, deprecate my APIs. Right? So when I release version 1.6, people compile against it, it still works, but it issues a warning saying that this is changing. And then in the next version, actually get rid of that type. Okay. So again, providing you a path in terms of semantics and meaning. So this would essentially end up in a situation like this in the IDE. You would have your type crossed out, and then there's a feature that I haven't shown here, but essentially there's going to be a comma here which says to you, replace with something else, and then in an IDE you'll just do Alt-Enter and it will replace it for you. Okay. Now we also try and provide semantics around destructuring of values, right? So Kotlin, when we first started with Kotlin, we decided that we should have tuples or tuples. And after a few versions, we dropped the idea because one of the main goals of Kotlin was to make code that is, in the words of Kevlin, not readable but comprehensible, right? And when you have tuples that return 20 values, it doesn't make sense anymore. So we got rid of tuples and we said you can only have pairs and triples, and anything beyond that you have data classes. But those data classes also, both with tuples and pairs and triples, data classes can be destructured. So here I get an instance of a customer. Here I can destructure that into ID, name, and email. Now if I'm not using ID, the IDE, the compiler, it's always going to complain to me and give me a hint saying that you're not using this value. I'm diminishing the intent of my code, which is where we can use things like underscore to say that this value is not being used. Those of you that are familiar with Scala, I believe that this has that as well. Limiting types. Okay. Now, here's a typical example where I have a class, data class, that returns a response. Okay? So I do a get page. If the URL is empty, then response not found 404, and then the actual result is going to be blank. If the response is successful, I will then set the message, the value to 0, and then I'll set the content. Now, when you look at that code, it looks like JavaScript, right? Because you don't know, when I say JavaScript, I mean it's obscure, crazy, pathetically bad code. That's what I mean. Not that the syntax looks like JavaScript. Okay? Yeah. Otherwise known as NPM-driven development. So the problem, of course, here is that, and actually this isn't JavaScript, because if it was, that would have been called M, not message, and that would have just been called E. And then you try and figure out, is that an event or an error? And as I say, in JavaScript, it doesn't really matter. So here what you have, the problem here, of course, is that I'm losing intent. When my method is returning an error, I have to figure out exactly what in my code, in my data class, is valid. When it's not returning an error, I have to figure out what is valid. Right? Because this same data class is being used to return results that are valid and return results that are not. Now you're thinking, this is crazy. Why are you doing this crap? We do it much better. We throw exceptions. Yes, exceptions are wonderful. Slight irony there. But anyway, what you can do, of course, is I can create nested classes. So I can say class success and class failure. And then I can say, in the case of response failure, then return a 404. In the case of response success, return the contents. Now here what I've done is actually I've split the values based on if it's a success or if it's a failure. Okay? And when I do this in Kotlin, automatically you see that there is no casting here again, because Kotlin the compiler will figure out that, oh, this is actually a response failure, so it only has a single property called 404, which is the error code. Oh, this is a success, so it only has a single property, which is the actual message, the actual contents. Now, of course, the problem here is that anybody could come and potentially, modify this or create another class that inherits from response. We try and solve that problem in Kotlin with sealed, right, which basically seals the hierarchy of the classes, right. This would be essentially what I'm creating here would be the equivalent of what's known as an algebraic data type, right, which is saying a type can have one type or another type. It's kind of like Boolean. The point being what? That this is clearly marking the intent of what my code is doing and separating the cases where it is a failure versus the cases where it is a success. So what else do we have? Now, one of the things that we try and do with Kotlin is extend functionality of many things. So here you have a string in Java, and you say, hello, how are you? And then I do value, and we'll create a new function called toTitleCase. The problem is we can't. It's red, right? The compiler is complaining. What can we do? We can create a public string utils, and then we can create a public static string toTitleCase, and then we can do string utils toTitleCase, right? That's a lot of stuff for just adding some function to some class. Now, we can also inherit from that class. Yes, we could, but we shouldn't really, because there is a slight problem with inheritance. With Kotlin, what you can do is extension functions, which essentially means I could take any class and extend it with new functionality. If you're familiar with C#, this is the equivalent of extension methods. The difference with C# is that I don't have to have a public static void class with a public static void method and then passing into this. This is how you declare an extension on string, right? And you just declare this anywhere, because in Kotlin, again, you can have top-level functions. You don't need to have all of these static functions, so to speak, wrapped in classes. Now, the good thing about this is that then I can just do value toTitleCase. So any type, whether it's a Java type or a Kotlin type, I can extend with new functionality. Now, this begs the question of, oh my God, now we're going to monkey patching and JavaScript again. Yes and no, because we can't delete things like we can in JavaScript. Second of all, these extensions are limited to the package scope. So you normally define these extension functions in specific packages, and then you use them. There are other techniques that people use, like, for example, creating interfaces and then extending these interfaces. Okay? We also have something that not C# doesn't have right now, which is extension properties. So how many of you work with big decimal? Probably no one, or don't put up your hand if you do. Okay, it's not something to be proud of, I heard. So here I have big decimal number equals calculate percentage, big decimal, big decimal. How many of you love writing big decimal over and over again, right? Now, in Kotlin, we can represent values in a different way. If I want to represent a float, I say 100f. What I would love to do is 100.bd or 100bd, something along those lines. And in fact, you can do that. What I do here is that similar to an extension function, what I am creating is an extension property, right? So essentially, I'm creating a new property .bd on integers, which is defined in the following way, right? It's basically saying extend the getter and return big decimal of this, which you can put even more concisely like that. And inline is a modifier which essentially means don't make this a function, but essentially copy and paste it for performance reasons. Okay? So with this, I can now just create, anytime I want to use big decimal, I can just do 3, 4, 5, 6.bd, right? Cutting down all of that boilerplate code, increasing, again, the focus on what exactly I'm trying to express. Okay? So similar to extension functions, you can do extension properties. Now let's talk about a little bit more code, not just single line code, and let's simplify a little bit patterns, right? This is credit go to Mario Fusco and Lovis. Those are their GitHubs. They've got the full examples. And what Mario Fusco did some time ago for a conference, he took the Gang of Four book that I mentioned, the Gang of Four patterns, and he converted all of those to using Java 8 and lambdas, right? And then what Lovis did said, well, I'll take your examples in Java 8 and I'll do them in Kotlin. And what I did was just copy and paste all of that and show it to you. But I took some good examples. So I took the examples that work really nicely for Kotlin. So visitor lambda, right? This is the equivalent of a visitor lambda in Java 8, right? So it's taking the lambda and it's essentially, the visitor pattern, and it's basically using lambdas to try and see what it can save, what it cannot. This didn't fit on the screen. I just basically did as much as I could. This would be the equivalent in Java, in Kotlin, that does fit on the screen. And I'm not measuring here the beauty of Kotlin based on lines on the screen. Don't get me wrong, right? So, you know, here I'm basically just creating the lambdas, and I've used this seal class that I spoke about. And you can see how easily now I can define different visitors, right? And I believe that that does, again, focus on the clarity of the code, on expressing the intent of the code, as opposed to all of this boilerplate that you find around the code to try and figure out what exactly it is doing. Here is an example of the observer pattern, right? So they've got the observer lambda, and I have the register, the observer, the unregister, the send event. Now, the equivalent to Kotlin is pretty much similar. There, you don't gain by much. However, you do gain by one thing, which is called by delegates.observable. In Kotlin, you can actually delegate properties. So instead of if you have a property on a class, you don't have to implement the same functionality over and over again. You can delegate it outside of that class to any function. We have a bunch of built-in functions. We have a bunch of built-in delegated properties inside the standard library. So when I want to create an observable property, all I have to do is say value by delegates.observable and then pass in my actual lambda that is saying what I want it to do, which in this case would have the property name, which I don't care about, so I use underscore, the old value, the new value, right? And then I update the listeners. Okay? Observable, vetoable, lazy. If you want to do lazy evaluation, there's a property that just says by lazy, and then the higher order function that you want to pass in. The decorator pattern as lambdas in Java, right? You're all familiar, the decorator enhances the functionality. Now, there's two versions of this, right? In Kotlin, you could just basically do, in a sense, you can extend it, right? You can extend that class and just say, you know what, I'll just create extension functions to add functionality to my class that I'm trying to decorate. Or you could take it to the next step and see decorator pattern for what it really is, which is composition of functions, and do the same thing with Kotlin. Now, if Kotlin doesn't have first-class support for functional composition, like Haskell does with the dot, but you can create a function that does functional composition for you. Okay? And now we can just basically compose these different functions as we like for them to do different things. Now, I was talking about the objects, that we have objects in Kotlin. So how would you implement the singleton pattern in Java? With a few lines of code. This is the singleton pattern in Kotlin, because an object only has a single instance. So if I just want a single instance of something, I just say object, the name of the object, and then whatever properties or functions I want to add to it. Okay? So a lot of these things, if we start to take into account conventions that we have in Kotlin, top-level functions, which means that I don't need the ceremony of a static class and then the static methods in that class, higher-order functions, which we've seen, and one other thing, which is lambdas with receivers, we can lead to code like this. Now, lambdas with receivers essentially is, you know what a higher order function is, right? Which is a function that takes a function and a function that returns a function. Given that in Kotlin we have extension functions, we can also pass in extension functions as parameters to functions, right? And that's what we call, no other language has this, so we've coined it lambdas with receivers, meaning that the lambda that you're passing in is part of an object, right, that is receiving that lambda. What that means is that I can now access properties, functions of that actual type that I'm extending. And this allows me to write code like this. This is completely statically typed, compilable, valid code, right? Accounting is a function. On creating invoice is a function. Log entry is another function. These are properties. Each of these are actual property function classes of Kotlin. Right? So if you're familiar with, for example, the HTML Groovy builders, or the Groovy HTML builders, although the HTML Groovy builder sounds good as well, if you're familiar though with those, you can basically do the exact same thing in Kotlin, but have it as static typing. And that's one of the reasons, like for instance, the Gradle now does Gradle Kotlin script, because they give you the benefits of Gradle with the benefits of static typing. So in summary, what I've tried to kind of highlight here, apart from selling you guys Kotlin, is syntax, in my opinion, contributes to clutter and noise. And if clean code is about comprehension, then it matters. If it is not, then you just got a good intro to Kotlin. It's for you to decide. Thank you. And since we have a few minutes, I can take questions, or you can get a much longer coffee break, either way.
I don't know if you, well, I'm personally interested in Kotlin versus Scala and where you think the industry is going to head with respect to take-up of the two, because I know Kotlin just got a boost because it got selected for Android's default language. So, yeah, do you have an opinion on that?
Yeah, I mean, my opinion on that is the same one that I've been saying for the past 5 years, which is generally if you are a happy Scala programmer, then you probably will not need Kotlin. It's as simple as that, right? Kotlin is restricted in certain areas of what you can and cannot do. Scala is not. Now, there are libraries such as one called Category, for instance, that is trying to introduce new things to Kotlin. Such as higher kind of types and things like that. But we purposely try to limit what is possible with the language to avoid situations where you could basically, I'm not going to say shoot yourself in the foot, but yes, shoot yourself in the foot. So, you know, beyond that, where the industry is heading, I cannot give you insight. Other than that I can say to you that, for instance, we create tools for Java, for Scala, and for Kotlin, and we're going to continue to create tools for all three languages.
Yeah, I have a question over here. Hi. Yeah.
Hey.
So I really like Kotlin. It looks like it's very well designed, very clean syntax and everything. One minor nit that I have is basically not having collection literals. And it's kind of interesting to notice that Java doesn't have them either. Is it really just a matter of going and having so many different collections that, you know, you wouldn't want to sort of like preference one?
Yeah, there is actually now, we've introduced a little bit collection literals in what would be the equivalent of 1.2 version.
Yeah.
However, it is limited to right now in annotations for, like, for example, in Spring. Allows you to annotate your classes, like instead of having to write array whatever. That's a kind of like a controversial topic, because there's defenders of that on the team and there's retractors of it. And the idea there is that, you know, one of the philosophies of Kotlin has been to not introduce too many things in the language syntax per se, but allow it to be standard library, additional libraries, right? And we kind of follow that same thing for asynchronous programming. So in asynchronous programming, we have basically, what we've done is we've generally implemented coroutines. And then we've not introduced things like async await keywords. All of those become library functions. Yeah.
Thanks.
Any other questions? Nothing. Okay. So I've got a question for you now. What do you think of the state of what's happening in Spain? No, I'm joking. How many people here from Barcelona? Right. So yeah, I was going to say a joke the other day, you know, you all know Fawlty Towers. Now it's like, don't mind them, from Barcelona. But anyway, no, my question is something related to this topic. Would you say that clean code in syntax has an impact on clean code or not? Yes. Okay, great. That's it. Okay, so you can go. Thank you.